Hey everybody, Mr. Rubo here. Today we're going to talk about the fundamental theorem of algebra. Um, the basics of it is that the total number of roots or solutions of a polynomial is equal to the degree of the polynomial. So if you have a cubic, so degree 3, you should have 3 roots. If you have a degree 7, you should have 7 roots. Okay, that's the fundamental theorem of algebra. Now, the way we're going to look at them in this class, at least, is we're going to look at the graph because if we look at the graph and we look at we can find the number of real roots by finding the x-intercepts of the graph. Okay, so knowing the degree, knowing the x, and looking at the graph and finding the number of x-intercepts, we can then find the number of imaginary or complex roots by subtracting the degree from the number of real roots. Okay, so if I were to tell you, let's just go down and get some room here. If I were to ask you to sketch a graph with a quadratic with a negative leading coefficient, I'll put LC for the, wow, that doesn't look like quadratic, and 0 real roots, well, according to the fundamental theorem of algebra, quadratic means degree 2, negative leading coefficient tells us it faces down, and then 0 real roots means there are no x-intercepts. So that would look like this. Right, so there's a quadratic, the parabola shape, and it's facing down because of the negative leading coefficient, 0 real roots, and it's not touching the x-axis. Okay. Let's say we had a cubic. So let me scroll down a little bit more. Cubic, let's say a positive leading coefficient, and then we'll say 1 real root. Well, for that, because it's cubic, we know it's either they're going to have the end behavior where they're opposites, either down then up or up then down. We decide that based off the positive, so it's going to have that like positive slope, if you will. 1 real root means that we're going to hit the x-axis once, and then we are not going to hit it again. So there's an example of a cubic with 1 real root because it would be right there. Okay. Now, something you'll notice or that you'll see is with our imaginary roots, so kind of going back up here, the number of imaginary roots will always be an even number because the imaginary roots always come in pairs. Okay. Okay. So you will never see just one imaginary root. You will always see 2, 4. You could have 0. But yeah, you will always see them come in pairs. Okay. So if I tell you the degree, you then know that there's that many roots. Looking off the graph, you can find the number of x-intercepts. That's the real roots. And then whatever would be left over would be your imaginary roots. Okay. So yeah, if I gave you a graph, let's say I told you this was a quartic, and the graph looks something like this. Well, quartic is 4th degree. There are 1 real, 2 real, 3 real, and 4 real. So this would have 4 reals and 0 imaginary roots. So yeah, it's really just comes down to counting x-intercepts and doing a little subtraction. So and obviously knowing your degree. All right. So yeah, thanks for watching and have a good day.